Astronomers have discovered a rare solar system with 6 planets moving completely in sync with one another, a perfect cosmic dance.
What is out there? In the darkness beyond the solar system, unimaginable wonders and terrors lurk. Imagine a universe where massive black holes devour whole star systems, rogue planets float pointlessly in space, and space-time is warped and distorted to infinity and beyond. Our understanding of the physical rules breaks down in this place, and the fundamental notion of reality is pushed to its boundaries. However, what is hidden even from our telescopes and the furthest reaches of our probes? What secrets await us in the uncharted territories of the intergalactic void? Some speculate that we may one day encounter extraterrestrial civilizations, their technology and culture far surpassing our own, and perhaps even glimpsing the true nature of reality. So join us as we explore what lies beyond the solar system. Our solar system is likely not completely foreign to you. If nothing else, you probably already know that it contains 8 planets, in addition to the Earth, the Sun, moons, and several other celestial bodies like asteroids and Pluto. But there's a whole lot more out there than what you know as the solar system. While the Milky Way is the most famous galaxy in the universe, the Andromeda Galaxy is just one of many others. Stellar remnants, interstellar medium, and star systems of varying types make up each galaxy. The exact number of galaxies in the cosmos is uncertain, although astronomers have put the estimate at 100 billion. Intergalactic space, which contains a thin gas, lies between the galaxies. When you consider how big our solar system is, and how many other solar systems there are in our galaxy, it becomes clear why the universe is believed to be endless. The enormity of the universe and our place in it is truly brought into sharp focus by this. The scale of things is hard to grasp. Even at its smallest, the 248,548-mile distance between the Earth and the Moon is enough to challenge the mind. The Apollo astronauts took 3 days to traverse that distance, a span that light, the fastest thing in the cosmos, takes a little over a second to cover. Things quickly get worse. We can have little hope of really appreciating the distance to the Sun or the orbit of Neptune. These are numbers and distances beyond human reckoning, relics of a cosmos so vast that our presence here quickly pales into alarming insignificance. Rather than miles, astronomers often speak of astronomical units, defined as the distance from the Sun to the Earth, or in terms of light years, the span covered by a photon of light in 1 Earth year. However, problems can arise even here. On the size of the planets, astronomical units, or AUs, are helpful. Neptune is about 30 astronomical units away, which is a more comfortable distance than 1.2 billion miles. Pluto, which was formerly considered to be the boundary of the solar system, never deviates from Earth by more than 50 astronomical units. But after that, a ring of frozen worlds around our solar system, known as the Kuiper Belt, could extend up to 100 AUs from the Sun. The Oort cloud, the birthplace of comets, lies even further away, its inner edge sitting some 2,000 AU from Earth. Its outer edge is still mysterious. Some speculate it extends halfway to Alpha Centauri, reaching as far as 200,000 AU. Here too, we need to adjust our measuring tools as we move from planets and comets to stars and galaxies. The ridiculously large distance between Earth and Alpha Centauri, 300,000 AU, is better described by scientists as being only 4 light-years away. You could be tempted to believe it's close, especially after learning that the galactic center is 26,000 light-years away. Be not deceived. The distance between Alpha Centauri and Earth is so great that there is little chance humanity will ever make it there. Even at the fastest speed we have ever reached, that of the Parker Solar Probe, traveling at 430,000 miles per hour, 690,000 kilometers per hour, it would take 10 days to cover a single astronomical unit. 4 light-years, if we could somehow keep that speed up, would take 7,000 years to cross. For the 5 spacecraft that are now leaving the solar system, that might sound like bad news. Even the most powerful spacecraft, Voyager 1, will complete its first light-year journey sometime around the dawn of the 21st millennium. By then, you'll be sorry to hear that Voyager 1 will long since have drained its batteries, leaving it far out of contact with whatever remains of the human race. Even though it's highly improbable that these daring explorers would visit other star systems, they are nevertheless returning valuable data to Earth. Even now, the border they have crossed, the one that separates our solar system from the rest of the galaxy, remains a mystery. Their data stunned researchers when they returned from crossing that border, prompting them to re-evaluate solar system theories. Their continued surprising behavior, now that they have entered the interstellar medium, is a mystery to scientists. Our solar system's immediate vicinity is shrouded in mystery. Voyager's instruments are essentially exploring new territory as it travels farther and farther away from Earth. Voyager 1, along with its partner Voyager 2,
3, 2, 1. MDS, we have ignition, we have a liftoff.
left Earth in 1977. Today, after over half a century in space, their age is beginning to tell. Both are powered by nuclear batteries, a fuel source that allows them to keep running even as the sun's light dwindles to almost nothing. Yet those batteries are gradually powering down, subject to the irresistible laws of radioactive decay. Their power levels will drop below the threshold needed to operate their antennas within a few years, according to NASA. The probes will go silent, and their operators will have no choice but to leave them once that happens. Pioneers 10 and 11, two of the earlier spacecraft, have already shut down and are already floating into the darkness by themselves. Only one spacecraft will remain to transmit data from the solar system's periphery after that. New Horizons, a probe launched in 2006, passed Pluto in 2015. It is now some 56 AU from Earth, a distance that still leaves it far short of Voyager 1's 160 AU. It should last into the 2040s, a time span that may allow it too to pass into the seldom seen interstellar medium. Our solar system joined the local interstellar cloud 60,000 years ago, long before our ancestors settled down and became farmers. Maybe the name is deceptive. Despite the fact that we refer to it as a cloud, the concentration of substance within it is quite weak compared to clouds on Earth. However, this cloud is a location of density, that is, one where gas and dust are present in somewhat larger amounts than they are in the surrounding environment. Now, after 60 millennia, the solar system is once again reaching the edges of this cloud. Researchers predict that we will break free of it and crash into the nearby G cloud in about 2,000 years. It's uncertain exactly what will happen when we cross that line, but scientists believe similar events in the past may have had an impact on our planet's climate and atmosphere. However, both of these clouds are part of a wider region of space known as the local bubble. We are situated in close proximity to the center of this bubble, which stretches outward for a minimum of 500 light-years in all directions. Within it, shockwaves resonating from a long-ago supernova have swept space clean, save for the odd cloud. According to the data, it erupted roughly 3 million years ago, at the same time that our ancestors started making stone tools. It's still up for debate how near the explosion was to Earth, but new evidence suggests it might have been. New evidence of iron-60, an element that can only be created in the center of a supernova, has been discovered in ice cores from Antarctica and sediments from the ocean. If a supernova had exploded close to Earth, it would have had a dramatic effect on the heliosphere, the protective shell of the Sun's magnetic field. This shell typically extends well beyond the outer planets. Its edge was more than twice Pluto's distance from Earth when the Voyager spacecraft approached it, at more than 120 AU. This shell would have shrunk, nevertheless, under the relentless pressure of the supernova's shockwaves. According to some research, its radius may have reduced to 25 AU, leaving the planets outside of Saturn vulnerable to debris from the dying star. Earth would almost certainly have remained within the protective shell. The existence of iron-60, on the other hand, indicates that we were not totally unharmed by the incident. As the Voyager spacecraft approach the end of their mission, scientists are considering sending a fresh crop of explorers to the solar system's periphery. First up could be the Chinese, who've sketched out plans to send 2 probes to 100 AU by the mid-century. Like many other Chinese space efforts, specifics about the mission are scarce, but some have come to light. With their divergent orbits, the two spacecraft would provide us with distinct perspectives of the heliosphere. The point directly in front of the Sun's direction of motion, known as the nose of the heliosphere, would be the target of one probe. The heliosphere would be seen more directly from the other, which would follow a more lateral route. It's unclear when they'll start, but it might happen as early as 2026. Prior to the decadal review of planetary science last year, American experts had outlined an even more ambitious goal. By the end of the next century, NASA might send a probe to 1000 AU. They concede that it would be difficult and take more than a century of operations to do this, but they maintain that it's not impossible. The so-called Interstellar probe may be able to take a ride on one of the large rockets that are presently being developed. According to baseline designs, it would be propelled towards the stars by NASA's moon rocket, the Space Launch System. However, alternatives such as Starship might become accessible soon, and provide a flight at a significantly reduced price. In any case, the probe would require a high rate of speed. The plan calls for it to pass Jupiter 7 months after launch, and to reach 100 AU within 15 years. The spacecraft would then glide toward 1,000 astronomical units, achieving that milestone around 140 years after liftoff. Designing a probe to last that long is tough, though Voyager has already made it close to 50 years in space. Maintaining communications over such large distances might be more challenging. The biggest obstacle, though, will be continuing operations for a 150-year period. Voyager stretched over the entire careers of some engineers, a length that made it hard to maintain knowledge amidst a fast-changing world. The Interstellar probe requires multi-generational missions, which means fresh perspectives on operations and technology. Perhaps we'd better get used to that. The scale of the universe makes us and our lifespans look puny. Reaching the edge of the solar system is a project measured in decades at best. Reaching the stars, if we ever do, will take generations. Let us know what you think in the comments section below. Don't forget to subscribe to our channel and put on notifications for more videos. See you soon.